For the past couple of days, we've spent some time solving equations with variables on both sides. It took us a little while, so I'm going to go through the process step by step, and if you have any questions, please make sure you ask either in class or send me an email or set up a time to meet with me outside of class. To start, we did an activity where we looked at various figures, and they said specifically that each figure's perimeter was going to be set equal to the area, and we had to come up with that equation for both of the figures. Before we could do that, we went through how to find perimeter and how to find area. Perimeter, we had to add up all four sides, so side 1 plus side 2 plus side 3 plus side 4. To find area, we had to do length times width. And what we came up with for these is once we found the perimeter, we're going to set that value equal to what we had the area for. So for example, on the first one, all I'm going to do is I'm going to label all of my sides so I don't forget anything, and I'm going to find the perimeter. The perimeter would be, got an x here plus an x here, which is going to give me 2 x's, plus then I have 3 here plus another 3 here, so I have 2 x's plus 6, and that is going to equal the area. The area is going to be length times width, and 3 times x would give us 3x. So then we can go through and solve for our variable. So I'm going to get all of my x's together. I'm going to bring the 2 x's to the other side, so I have to subtract them from both sides in order to get them over to the other side. That leaves me with 6 equaling, and 3x minus 2x gives me 1x, or just x. So we're going to come down to the next shape. I'm going to first find the perimeter, so I've got to label all of my sides. I've got 2 x's, plus then I've got a 4 here and a 4 here, which gives me 8. I'm going to set that equal to the area, which is going to be length times width, which is 4 times x, which gives me 4x. I'm going to get all of my x's together by subtracting 2 x's from both sides. That leaves me with 8 equaling 2x. Since my x is not yet alone, I see it's connected to a number. By multiplication, I'm going to undo that multiplication by dividing. And in this case, x is going to equal 4. On the next one, I'm going to label all of my sides. The perimeter is x plus x, which is 2x, plus, and then 18 plus 18 gives me 36, and that is going to equal my length times my width, which is 18 times x, or 18x. I'm going to get all my x's together, so I'm going to subtract 2 x's from both sides, which leaves me with 36 equaling 16x. The x is not yet alone, so I've got to divide by 16 on both sides. X is going to equal 36 divided by 16 is 2.25. When I moved to slide D, you'll notice that we have a fraction on here, and a lot of times students would prefer working with decimals. So I'm going to change this 5 over 2 to 2.5, because 2 fits into 5 2 times with 1 left over, which would be 2.5, or might be easier to just use 2.5. So I'm going to label all of my sides. Then I have to find the perimeter. I've got an x here and an x here, which is 2 x's, plus then I've got 2.5 plus 2.5, which is 5, and that's going to equal my area, which is 2.5 times x, or 2.5x. So now I'm going to get all of my x's together. I'm going to take away 2 x's from both sides, which leaves me with 5 equaling 2.5 minus 2 would be 0.5x. I've got to get that x alone. Since they're connected by multiplication, I'm going to divide. 5 divided by 0.5 gives us 10. Another way to ask yourself that question is how many halves fit into 5, and there would have to be 10 halves that fit into 5. So then we started getting to the point where we had to solve some equations. This was in our practice journal. So we wanted to get all of our x's together. So I subtracted x from both sides. Remember, that's like a 1x if you wanted to sneak in that 1 so that you know what number you're dealing with. Leaves us with 16 equaling 9x minus 1x would give me 8x. To get that x alone, I've got to divide, and x equals 2. So then we went to the next couple of problems where we had to do the same thing. We were setting up the perimeter and the area, but since there are two shapes combined, you have to combine the area of each individual shape. So on this first one, since right here is 1, I know down here is 1. Since right here down below is x, that means this is an x. And then over here, since this whole side is 3, and we know that this is 2, this also needs to be a 1. So when I'm finding my perimeter, I've got an x here and an x here, which gives me 2 x's, plus then I've got 1 plus 2, which is 3, plus another 1 gives me 4, plus another 1 gives me 5, plus 3 gives me 8. So I have 2x plus 8, and I have to set that equal to my area. Well, first I'll find the area of this smaller rectangle, which is 1 times 2, or 2, plus, now I have to find the area of this shape here, which is a 3 by x, or 3 times x, which is 3x. What we noticed is that both sides have x's and both sides have numbers. So just like before, I'm going to get all of my x's together. That's going to be my first step. So I'm going to move these 2 x's to the other side by subtracting 2 x's. And the only place I can take away those x's are where we also have x's. So I'm going to take the 2 x's from the 3 x's. So I'm left with 8 equals, I still have this 2, plus 3x minus 2x is 1x, or just x. That now we look at our x and we notice that it's connected to that plus 2, so we want to get it by itself. So we're going to subtract 2 from both sides, which leaves us with 6 equaling x. On the next one, again, I'm going to label the missing side so that I can find my perimeter. When I find the perimeter of this shape, I have an x plus an x. Those are my only x's, so I have 2 x's. Then I have to figure out the number portion. So I've got 2 plus 1, which is 3, plus 4 gives us 7, plus 1 gives us 8, plus 4 gives us 12, plus 2 gives us 14, plus 2 gives us 16. So we have 2x plus 16. Then we find the area of each individual shape. This is a 2 by x, or a 2x, plus, then over here, we have a 4 times x plus 1. We have to remember to do the distributive property, which gives us 4x plus 4 times 1 gives us 4. So I'm going to combine my like terms. These 2x's plus 4x's gives us 6x. So I have 2x plus 16 equals 6x plus 4. Again, I'm going to get all my x's together by subtracting 2 x's from both sides. That leaves us with 16 equaling 4x plus 4. To get these x's by themselves, I'm first going to subtract 4 from both sides. I'm going to get 12 equals 4x. The x is still not alone. It's connected by multiplication, so I'm going to divide. And in this case, x equals 3. On this next one, I'm going to label all of my sides. So this would be a 3. Since this whole piece is 3 x's and you see 2 x's down here, I know that this is going to be an x. Since this is 1, this is 1, this is 1, and this is 1. So when I'm finding the perimeter, I have 3 x's right here, plus another x, that would be 4x, 5x, I have 6 x's, plus I've got 3, 6, 7, 8, 9, 10. So 6x plus 10 is going to equal, down here I've got a 1 by x, which is just 1x. I've got another 1 by x, which is just 1x. And I have 3x times 3, which would give me 9 x's for a grand total of 11 x's, because 9x plus x would give me 11x. I'm going to go ahead and solve, get all my x's on one side, which leaves me with 10 equaling 5x. I have to divide both sides by 5 to get that x alone. It's connected by multiplication, so I had to undo that, and x equals 2. So then we did some more practice problems in our practice journal. On number 2, we're going to get all of our y's together. So in order to do that, I'm going to take away these 4 y's from both sides. Because if I had 4y and I wanted to get rid of them, I'd have to take them away. When I do that, I have to be careful because I still have a minus 70. 12y minus 4y gives me 8y plus the 2. To get that y by itself, I've got to subtract 2 from both sides. Remember, when they're the same signs, you add them. That gives me a negative 72 equaling 8y. To get my y by itself, I divide by 8 because they were connected by multiplication, and I've got to undo that. And in this case, y equals negative 9. Number 3 had a couple more steps because we first had to distribute. When 5 shakes hands with the p, we get 5p. When 5 shakes hands with the 6, we get 30. We're going to take the 5 p's to the other side so we can get all of our p's together. That leaves us with 30 equaling 3p. We have to divide both sides by 3, and in this case, p equals 10. Okay, over here we've got to distribute again. When the 5 shakes hands with the p, we get 5p. It looks like we have this one on there twice, so I'm going to just cross it out. We don't need to do it again. Number 4 also requires the distributive property. When the 3 shakes hands with the g, we get 3g, minus when the 3 shakes hands with the 7, we get 21, equals, now the 2 has to shake hands to give us 20, plus the 2 shakes hands with the g to give us 2g. A lot of students like to keep it, change it, flip it with subtraction. I'm going to get all of my g's together. I'm going to choose to bring these 2 g's over to the other side so that I can deal with positive g's. So I'm going to take away 2 g's from both sides, which leaves me with 1g, or just g, plus negative 21 equaling 20. To get rid of that negative 21, I'm going to add 21 to both sides. And that's 1g, or just g, equals 41. On number 5, we had to get all of our like terms together. I'm going to get rid of this 1.8 by subtracting 1.8 from both sides. That leaves us with 7n equaling 7.7 minus 4n. Now we want to get our ends together. Because the ends are on the left side by themselves, I've got to move my minus 4 ends over, so I'm going to add 4n to both sides, which leaves me with 11n equaling 7.7. Finally, I have to divide by 11 on both sides, and n equals 0.7. A lot of times students go to take away, right up here, they go to take away 7n from both sides, and what happens is they are left with 7.7 plus 11n, and they got rid of everything on the left-hand side. We don't want to do that because then we don't have the n by itself. We've totally dropped off our equal sign, and we don't want to do that. On the next one, we're going to get all of our w's together. Since they're over here by themselves, I'm going to get these other ones moved over. So I'm going to subtract 3/7 w from both sides. Since they're the same signs, they're both negative. 4 plus 3 gives us 7, so it's going to be negative 7 over 7 w equals negative 11. The negative 7 over positive 7 would be a negative 1, so negative 11 equals negative 1w. Divide by negative 1, and w equals 11. On the next part, we had to deal with surface area and volume. And surface area, we had to find the area of each face. So we'd find the area of this box, the area of this box, and the area of this box. And since they always have a side across from it, we know we have 2 of them. Then we also had to find volume, which was length times width times height. So the area of side 1 plus the area of side 2, and so on. However many sides the figure has. And they told us that the surface area was going to equal the volume. The volume's the easiest to find because you just do length times width times height. So 6 times x would be the volume, which gives us 36x, and we have to set that equal to the surface area. So first I'm going to find the area of this side, which is the 6 by x, which is 6x. Now we also have the side on the back, so we've got 2 that have the 6x, plus, now I have to find the area of this side, which is the 6 by the height here is also x, so I've got 2 more sets of the 6x. Plus, then I have to find the area of the top. When I follow this up, right here would be 6, over here would be 6, and 6 by 6 gives us 36. So we have the top and the bottom of that cube, so we've got 2 sets of 36. When we reduce, we get 36x equaling 12x plus 12x plus 2 times 36 is 72, which reduces down to 24x plus 72. We want to get all of our x's together. Since the x's are alone on the left-hand side, we're going to bring them over there. We're going to subtract 24 x's from both sides, which leaves us with 12 x's equaling 72. To get the x's alone, we have to divide by 12, and x equals 6. For letter B, we have to, again, find the surface area and the volume. The volume's the easiest. So we have 4 times x times 8, which gives us 32x, equaling, we have to find the area of each surface. So we have 2 sets of this. The 4 by x gives us 4x. We have 2 sets of that. Plus, we have to find 8 by 4, which gives us 32. We have 2 sets of the 32. Plus, we had to find the top, which is an x by 8. 8 times x would give us 8x, and we have the top and the bottom, so we have two sets of 8x. That gives us 32x equals 8x plus 64 plus 2 times 8x is 16x. We can combine our x's here. So we have 32x equals 24x plus 64. We want to get our x's together. Since they're alone on the left-hand side, I'm going to subtract 24x's from both sides, which leaves us with 8x equaling 64. To get the x alone, we've got to divide by 8, and x equals 8. For the next part, we have to set up an equation that shows that the perimeter of the larger triangle is 150% of the perimeter of the smaller triangle, and we have to find the dimensions. So with this, we are creating an equation. I'm going to move over to the next one to solve. So you'll notice that it says the perimeter of the larger triangle. So we're going to actually figure out what that is. The perimeter of the larger triangle is 15 plus 9, which is 24, plus we also have this 2x. The word is in math means equals, so I'm going to set that equal to 150%. If I were to write that as a decimal, would be 1.5. Of in math means to multiply the perimeter of the smaller triangle. So the perimeter of the smaller triangle is 8 plus 10, which is 18, plus x. I'm going to take that and I'm going to write it on the next slide so that we can have some space to solve. So we have 24 plus 2x equals 1.5 times 18 plus x. So when I go through and solve this, I have to distribute over here. So I still have my 24 plus 2x equaling 1.5 times 18 is 27, plus 1.5 times x is 1.5x. I want to get all of my x's together and all of my numbers together. I'm going to start by taking away 24 from both sides, which leaves me with 2x equaling 3 plus 1.5x. I want to get all of my x's together, so I've got to move them to the left side because that's where my x's are alone. So I'm going to subtract 1.5x from both sides. 2x minus 1.5x is going to give me a half of an x equaling 3. Divide by 1/2, and x equals 6. Now we're going to go through and solve a couple equations, and we can go through and check our work. So for this first one, if we want to get our x's together, you'll notice that they're not alone here, so we're going to start by adding 2 x's to both sides. Negative 7x plus 2x gives me a negative 5x. The x's aren't alone, so I've got to divide by negative 5, and x equals negative 3. If I want to check, I'm going to plug back in. So the 15 minus the 2x, what I get for that, should equal the same as what I get for the negative 7x. So we're going to plug in that negative 3 for both. So here I get 15 minus 2 times negative 3 is negative 6. We keep it, change it, flip it, which gives us 21. And the next side, negative 7 times negative 3 gives us 21. Since they're the same, we know we got it right. The next one, we've got to get our r's together. Since the r is alone on the left-hand side, we're going to bring the others over. We're going to add 15 r's to both sides, which gives us 16r equaling 18. We've got to divide both sides by 16. R is going to equal, 16 goes into 18 once, with 2 leftovers, which is the same as 1 1/8. If we wanted to go back and check our work, it would mean 1 1/8 would have to equal negative 15 times 1 1/8 plus 18. So we get 1 1/8 equals negative 15 times 9/8 plus 18. I'm going to make that a fraction, which gives me negative 135 over 8, plus I want to make 18 a fraction over 8, so I'm going to multiply both the top and the bottom by 8, which gives me 144. So I have 144 minus 135 gives me 9 over 8, which is the same as 1 1/8, so that one does work out. On the next one, we have to use the distributive property, so the negative 2 wants in. I'm going to keep it, change it, flip it. Negative 2 shakes hands with the x to give us negative 2x, plus negative 2 shakes hands with the negative 5. Two negatives give us a positive 10. Here, 6 shakes hands with the 2 to give us a 12. I'm going to keep it, change it, flip it. And now we have to have 6 shaking hands with negative 1/2. Well, half of 6 is 3. We have to include the x. And because there's a negative sign, it's going to stay negative. I'm going to start combining everything together. Remember, we wanted our x's together and we want our numbers together. So I'm going to start by getting our x's together. I'm going to choose to move these x's to the left-hand side by adding 3 x's to both sides. Negative 2x plus 3x gives me 1x, or just x, plus 10 equals 12. And then I have to subtract 10 from both sides to get x equals 2. The next one, we're dealing with more positives, but again, the distributive property. When 2 shakes hands with the x, that gives us 2x, plus when 2 shakes hands with the 1, we get 2, equals. When 6 shakes hands with the 1, we get 6. Not equals, sorry, it should be a plus sign. When 6 shakes hands with 1/2 x, we get 3x. I'm going to start by taking these 2 x's over to the other side. So we get 2 equals 6, and then 3x minus 2x gives us 1x, so plus 1x, or just plus x. Now to undo this plus 6, we've got to subtract 6 from both sides. 2 minus 6 gives us negative 4. If I wanted to go back and check my work, I'd have 2 parentheses instead of the x. I'm going to put in negative 4 plus 1. We're going to check to see if that's the same as 6 times 1 plus 1/2 times negative 4. Well, negative 4 plus 1 gives us negative 3. 2 times negative 3 gives us negative 6. We're going to check to see if that works. 1/2 of negative 4 would be negative 2. And 1 plus negative 2 is negative 1. 6 times negative 1 gives us negative 6. Over here, because the x's are alone on the left-hand side, we've got to get rid of these x's on the right. So we're going to subtract 2 x's. So we get negative 5 x's. They're the same sign, so we add them. It stays negative. Equals 19. Divide by negative 5. X equals. 5 goes into 19 3 times with 4 leftovers, and it's negative. The next one, I'm going to move these y's over here by subtracting 2.5 y's from both sides. That leaves us with a positive 6 equals 4.5 minus 2.5 would be 2 y's minus 1. Now we've got to get the y's alone, so I'm going to add 1 to both sides. That leaves us with 7 equaling 2y. We have to divide both sides by 2 to get that y by itself, and y equals 7 divided by 2 is 3.5. Problem 3, we had to distribute. So we have 6 times 4, which is 24, minus 6 times z, which is 6z, equals 2z's. We want to get our z's to the side where they're by themselves, which is over here, so I'm going to add 6z's to both sides. 2z plus 6z gives us 8z's. We divide both sides by 8, and z equals 3. Now we get to a special case. You're going to notice something a little bit different when you go to solve equations like this one. So I'm going to choose to move my x's to the right-hand side. So when I do that, I'm going to add 4 x's to both sides. That leaves me with 3 equaling a negative 7. And then you'll notice that these two cancel out as well. So I'm left with 3 equals negative 7. Well, if you stop and think about it, 3 does not equal negative 7, so you can put a big slash through the equal sign because it does not equal negative 7. Therefore, you have no solution. Anytime you come up with an answer where the left side does not equal the right side, you're going to put down no solution. So let's try another one. So if I were to add 5, let's say I wanted to get rid of my numbers first. So I went and added 5 to both sides first. So I get 3x equals 12 plus 3x. So then I have to get my x's together. So I'm going to subtract 3 x's from both sides, which cancels these out. 3x minus 3x is 0. I get 0 equals 12. Well, 0 does not equal 12, so I can put the slash through it, and I get no solution. So whenever you have the left side set equal to the right side, but it's not the same number, you can put a slash through it and write no solution. So now I'm going to go through and do the next example. There's nothing I can do on the left-hand side, so I'm just going to bring down that 6x plus 4 equals. Now I have to multiply 4 times 3 halves. Remember, we're shaking hands. Plus 4 has to shake hands with the 1. So I'm going to make that a fraction, and then 4 times 3 gives me 12. 1 times 2 gives me 2, and we still have that x. Plus 4 times 1 is 4. I can reduce this. The 12 over 2 is the same as 6. So I have 6x plus 4 over here. I have 6x plus 4 over here. You'll notice that the left side is identical to the right side. Therefore, we have infinitely many solutions. And what that means is no matter what I plug in for x on the left-hand side, it's always going to equal the right-hand side. So if I plugged in 1 on both sides, I'd have 6 times 1 plus 4, which is 10, on both sides, and they'd be equal. I could plug in a 2. 6 times 2 is 12, plus 4 gives us 16. Both sides are going to be equal. No matter what I plug in for my x, they're going to be equal because they're the same equation. So let's try the next one. We have 1/4 needing to shake hands with the 8 minus the 1/4 has to shake hands with the 12 equals 2x minus 3. Remember, when it's shaking hands, since this isn't a fraction, you have to make it one. Top times top would give us 8. Bottom times bottom would give us 4. And we still have that x. Minus top times top gives us 12. Bottom times bottom gives us 4. We can reduce these fractions. 8 over 4 is 2x. Minus 12 over 4 is 3. And you'll notice again, the left side is exactly the same as the right-hand side, and when they're always the same, you're going to have an infinite number of solutions. So we've got infinitely many solutions. So then we tried a couple on our own. You'll notice that these two look the same, but they're not identical. So we have to go through and we have to solve. So I'm going to get rid of this minus 1 by adding 1 on both sides. So we have 2x plus 2 equals 2x. We want to get our x's together. That leaves us with 2 equaling 2x minus 2x is 0. we ask ourselves, does 2 equal 0? No, it does not, so we have no solutions. Number 5, the 1/2 has to shake hands with the 6t. What's 1/2 of 6? Since we're multiplying, we can ask it that way. That would give me 3t minus 1/2 of 4. So when I did 1/2 of 6. And then we did 1/2 of 4, which is going to give us 2. And then we have equals 3t minus 2. When I go through, I could get rid of this negative 2 by adding 2. That gives me 3t equaling, this is gone, 3t. They're the exact same, which means we have an infinite number of solutions. So we can say infinitely many solutions. So now we come down here, we have 1/3 of 2b. So the 1/3 has to shake hands with the 2b, plus the 1/3 has to shake hands with the 9, equals, now the 2/3 has to shake hands with the b, plus the 2/3 has to shake hands with the 9/2. So we're going to make everything that's not a fraction. And we'll go through and we'll reduce. 1 times 2 is 2 over 3 with our b, plus 1 times 9 is 9, 3 times 1 is 3, equals 2 times b, 2b, or 3 times 1 is 3, we've got our b, plus 2 times 9 is 18, 3 times 2 is 6. We can reduce whatever fractions can reduce. 2/3 can't be reduced, but 9 over 3 can, so we have 2/3 b plus 3 equals 2/3 b plus 18 over 6 is 3. You'll notice they're exactly the same, which means we have infinitely many solutions. I'm going to have to erase just a little bit because I kind of got in that area. So on the next one, the 6 is going to shake hands with the 5 to give us 30, minus 6 shakes hands with the 2v to give us 12v, equals, here we've got negative 12v plus negative 4. If I get rid of the minus 12v, I'll add 12v to both sides, which leaves me with 30 equaling, that's 0, and minus 4, which does not happen, so we have no solution. On this next one, it says the circles are identical. What is the area of each circle? Well, since this top one only gave us half, if we drew in this other half, we'd have another x plus 2, which equals down here. So if the x plus 2 plus the x plus 2 is all the way across on the green circle, that's got to equal all the way across on the purple circle, which is 4x. If I were to simplify everything, I have 2x's plus 2 plus 2 is 4 equals 4x. We want to get all of our x's together, so I'm going to subtract 2x's from both sides. So I get 4 equals 2x. We'll divide both sides by 2. X equals 2. But that doesn't answer the question. The question is, what is the area of each circle? Well, area of a circle is pi times the radius squared. So I'm going to plug in what I know. Pi times our radius would be, plug this in, 2 plus 2, which is 4 squared. So our radius I just found here by plugging in that 2. So area is going to equal pi times 4 squared, which is 16. So area equals 16 pi. Down here it says the legs of the right triangle have the same length. What is the area of the triangle? So I'm going to set this length equal to this length and figure it out. So we have 3x equaling 2.5 minus 2x. I'm going to get our x's together by bringing them over to the left-hand side. So I get 5x equals, I'm going to call that 2.5. We'll divide both sides by 5, and x equals 1/2. And again, that's not answering the question. The question is, what is the area of the triangle? So here, this 3 times 1/2 would be 1.5. This one's 1.5. And then here we have 2 times 1/2. So we have 2.5 minus 1, which is 1.5. Again, they mean the same thing. So we have base times height divided by 2. So we have base, which is 1.5, times the height, which is 1.5, and we have to divide that by 2. So the first thing we're going to multiply is 1.5 times 1.5, which gives us 2.25. Divide it by 2, and we get 1.125 is the area. We'll say units squared. For this one, we have to use the picture to help us come up with an equation. So here we've got the distance upstream, and then here we have the distance on the return trip home. So the distance upstream would be 3 times x miles, and then the distance of the return trip would be 2.5 hours times however many miles plus 2 miles per hour faster. So we're going to go through and solve. So we have 3x equaling 2.5x plus 2.5 times 2, which is 5. We'll take away 2.5x from both sides. That leaves us with 0.5x equaling 5. Divide by 0.5, and x equals 10. So to answer the question, the boat travels 10 miles per hour for 3 hours upstream, which gives us 30 miles. So we've got another example that's similar to the last one. So when we go through this one, we're traveling 3 hours downstream at r miles per hour, and we're going to set that equal to the return trip home, which took 4 hours, but we were traveling r minus 5 because it was going slower, so we had to subtract out that. So we're going to go ahead and distribute. So we still have this 3r. That's going to equal 4r minus 20. We've got to get our r's together, so I'm going to subtract 4r's from both sides, which leaves me with negative 1r equaling a negative 20. Divide by negative 1, and r equals 20. We have to go back in to figure out the distance, so 3 times 20 would give us 60 miles. And on the return trip, if we plugged in the 20, we would do 4 times 20 minus 5, which is 4 times 15, which also gives us 60. If you have any questions, please don't hesitate to email me, sullivan@milton.k12.wi.us, or ask me in class. This was a very challenging lesson, so please bring your questions to me so that you can feel better about this before you go on to your homework.